It's Don here from the board. Thanks for coming along and checking out this video. So I finally have a chance to actually try out the EMC8000 calibration microphone. My wife is taking the kids out to go and do some shopping, so it is daytime, so there is still going to be traffic noise and things like that, but it's probably the best opportunity that I've got right now to give this microphone a go and see how it compares to the other microphones. So what I've got set up is on the desk with the boom arm now. The microphone is pointed to the middle of the keyboard, sort of sitting around that G and H position. It's sitting about 2 inches from the actual keyboard, kind of similar-ish height, I suppose, probably a little bit lower than previously on the other microphones. I didn't really go back and check and calibrate how high that was, but for the purposes of just checking it out, I think this will be okay. The cable is just running off that and across to the mixer. So what you're hearing me on right now is actually my ribbon microphone, which is my normal NTR. But what I'm going to do now is I'm just going to switch over to the calibration microphone because it's going through the same mixer. So I'm going to turn down the volume on the ribbon and I'm going to turn up the volume on the calibration. So now what you're hearing is what I sound like on the calibration microphone from a downward angle. So from this table view, I'm talking from this way of the thumb direction. It is really interesting because I can see it here on OBS and you can see it here at the top of the screen that the microphone is picking up just fine. So its sensitivity is actually really great, and when it talks about being omnidirectional, it seems to be doing the job really, really well. So what I've got for this setup is on my other screen, I've got Monkey Type and I've got Audacity running. So this is what you can see here, and you can see it's now just on the calibration microphone and it's picking up quite well. So I'm going to set it recording. I'm going to let it have a bit of background noise to it, and then I'm going to do the 1 minute typing sample on Monkey Type like I did with the other microphones, and then we can do some analysis afterwards. I'll obviously have to cut that and slap it into the graph and check it out in terms of what it looks like afterwards. But I think it should be interesting. Okay, so here we go. Zip up silence mode and background noise. Okay, cool. So still sitting in sort of that 90 word per minute area and around that 98% accuracy, which is very similar to what I was doing on those other keyboards. So I'm going to make sure that I save this file, but actually let's just do a little bit of editing at the moment just to show you what I would normally do. So around 4 seconds or so was when I was after the click. So I'm going to go and grab the noise reduction on that, grab that profile, going to select it all, and then I will do the noise reducing. So that's going to go blip,
and then from that 10-second mark, I'm going to get rid of that. And that is effectively the sample. I'm going to go down to the end where it stops. I'm going to cut that, and then we can grab the whole thing, do the analyze, plot spectrum, only 54 seconds, that's fine, and it turns out to be looking like this. Now, I don't know off the top of my head how that compares to the other microphones, but what I'm going to do there is I will export that data, and then I'll put it into Excel with the other graphs, and then we can check it out in the next part of the video. So I will see you in after the editing chop.
Alright, so we are back from the other side of the editing where I did that data processing. What I've done now is I've switched back to the NTR microphone, so it should be a little bit back to normal on how I sound. One thing that I did notice is that the actual volume, I think, from the calibration microphone is actually much lower, and that was from the actual data that I saw. It's also probably because the actual size of the microphone pickup is so small, but that doesn't matter. I think the shape is probably going to be more important. Now, in terms of context of how this is set up, by the way, that you can see here, I took a snapshot just with my phone and I've just put it up into the other screen. So I just want to show you what it looks like, and it looks like this. So what I've got here is I bought a 10-pack of M20 weights. Well, they're washers, right? Big construction washers, 75mm by 75mm by 5mm thick. The 10-pack weighs quite a bit, and the entire base stand without the boom arm used to weigh, I think, 1.2 kilos, and now it weighs 3 kilograms. I actually took the rubber feet off because the 4 rubber feet, while they're supposed to provide dampening, was making it unstable, and it just sits on one of our dining stools. Does fantastically well. You can see it stretches out over the keyboard. I have it positioned in a certain way that allows me the best possible access to what I'm trying to do. So that's the setup. Now, in terms of what's actually happening, here is the new graph with the ECM8000. Of course, I keep forgetting that the screen aspect ratio is not fantastic, so I'm going to have to manually adjust this. There we go. No, went too far. There we go. Is in this light pink, and this is what I was talking about just then. It's actually producing a lower decibel value compared to the other microphones. Now, the other microphones were all using the same gain and level controls, which I am using this probably with a different setting, right, to that. When I was setting up this microphone, I've got the level control to the same, which is at the 12 o'clock position, but the gain position, I probably don't have it at the same control because it's an analog dial and it's a little bit fiddly, so how loud it is, it's really hard to tell. What I'm more focusing on at this point in time is the shape. The shape is probably more important simply because, well, the shape is what we kind of discussed previously with the other microphones. And despite the fact that you're going to have volume differences in how sensitive the pickups are, because the NTR being a ribbon microphone, being the loudest makes sense simply because it's the most sensitive pickup type. This is a condenser pickup, not a ribbon pickup, so it's going to be obviously less sensitive. And also because it's so small, it's going to be, once again, less sensitive. So it being a lower volume could be an effect of both my mixer setup in the gain, as well as the fact that the microphone itself and its design and build. But the shape is what's really, really interesting in how it picks up. This is meant to be a calibration microphone. It's meant to be flat across the normal hearing range and only towards the higher frequency range that it does a little bit differently. And what we can see here on this is the shape here is actually very consistent, very similar to the blue one, this nice dark blue one, which is the ribbon microphone, which was at the time what I had to be closest to a flat response that I believed I had. As we run up the frequency past 2000 into 3000, and so you once again see a little bit of a drop off, very similar, but unlike the ribbon microphone where you have the secondary hump, it continues to fall off, and then you get into some of this strange squiggle stuff over in the 8000 plus range, which from what I've had discussions with somebody who actually works in audiology, over 8000 kilohertz is really quite insignificant for most people. They don't really care that much about it, even though we can hear up to 22 kilohertz, which is what I've cut the graph off here at this point in time. So for what it's worth, this calibration microphone does two things here, in that it backs up and correlates how nice and flat the ribbon microphone actually produces, but it does actually show a difference in this higher frequency in what we're hearing. What does this mean? What does this mean? Well, relative to the frequencies, my keyboard doesn't have a lot of the lower frequency bass. There's a bit of this mid-tone kind of stuff here that's happening around the 1000 odd, 2000, falls off around that 3000 point, and then it doesn't have a lot of super high sort of tinny sounds, right? Most of the data correlates quite nicely. They all behave in that way for most part. The waves are a little bit funky somewhere here in the middle around that 3000 point, but noting the other microphones are designed for voice pickup, right? And for recording purposes, specifically to create more warmth, for example, in some of these microphones, that is kind of expected because they're designed to add feature and color into the sound. This this calibration microphone doesn't care anything about that because it's trying to represent true. So I'm actually really happy to see that it follows the general curve. It's not doing anything dramatically different, but there is some visible differences, especially compared to the Snowball, right? You can see the Snowball is doing all sorts of weird things that doesn't follow the other microphones. And I suppose from the NT-USB, the NT1, and the AT2020, they actually have a very similar fall down curve and peak up to this calibration microphone. What does all of this mean? What does all of this mean? Why are we doing all of this at all? Well, let's rewind back to what I was saying in terms of the premise. Trying to find a suitable microphone and setup that will give you an accurate representation of the keyboard sounds that you hear for an affordable price, okay? So that everybody potentially could use the same setup, and therefore the sounds that they're recording will be as close as possible to reality, which means everybody's sound samples can be compared to each other rather than a whole bunch of different microphones. So you can see by this, just with the microphones that I've been using, there is a lot of variation in it. Now, in terms of price, the ECM8000 producing a very similar curve to a lot of the microphones, and I think giving quite a nice representation of what the others are picking up and showing, is very cheap. It's $50 odd Australian just for the microphone. Now, you can spend a lot more and eliminate some of the issues that come with the ECM8000. ECM8000 requires an XLR cable, different quality cables. It requires a mixer, different mixers and preamps and all of that kind of stuff. There are other calibration microphones out there that have USB built into it, and therefore it will go straight to the digital signal to your computer, which would eliminate the issues of different controls, different preamps, and the equipment within that audio chain. But the cost goes up, right? We're talking about 3, 4, 5 times the cost for a USB calibration microphone. I didn't want to go and spend that cost simply because I do have a mixer set up to it, and if I was to use this again, I know what I've got going on over here at the moment. If I record that diligently, then it means into the future, using this calibration microphone to compare apples to apples, it would allow me to do that. I can use the same boom arm with the same stand, with the same cable, with the same approximate positioning. You know, it's about a hand width off from the actual keyboard. So what I mean by that is, you know, if I go to here, you know, I can fit my finger to the actual keys right there, and that is a, you know, good height position to work with, right? Because my finger width's not really going to change there. Of course, other people it might, but to be honest, how high and how low it is to the keyboard is only going to be an amplification issue, right? The ratio of the sound, for most part, should be okay. You can amplify these signals and, you know, get that line to move up and down, as it were, right? You're not realistically going to be making those curves stretch if the whole signal is just being boosted up and down. So I think this is probably a really good way to go about it. I don't know if it's going to be something that will ever be adopted by other streamers or other people in our community, but calibration microphones exist for a purpose, to calibrate things, right? They're meant to be relatively standardizing. It's the whole thing about calibration. Maybe let's have a push to get our community to do keyboard samples, typing test samples, switch samples, whatever you want to say, right, into a calibrated setup, into, you know, picking something that everybody could potentially relatively afford and using that. This might not be the best choice simply because of the mixer issue. Maybe the next one up, or the cheapest available USB one, the UMix 1 or 2 or whatever it is that somebody had commented on the previous video about this, you know, that could be an option. In any case, I hope this gives you a bit of food for thought, because it's certainly given me a lot to think about in the context of what we do and why we do it, what are we looking for, and how do we perceive these sounds. One thing that I do want to show that's really interesting is I rescaled it, right, to 22,000 hertz, but here it is at the full spectrum. Everything falls off and there is this noise level at the high frequency, which is just stuff, right? It doesn't really technically matter. This stuff is just, it's just inherent to the microphone and its internal noise that it's generating, the frequency, its electronics. But look what's happening here. On the ECM8000, it just falls right through the bottom. Right through the bottom. I mean, there's only about, you know, between this line and the majority of them about 10 decibels, about 15 decibels to the NTR, but then on this end, it's just crashing right through, which is really, really interesting because it must be designed to not bother picking up frequencies past that level, simply because the designers of this microphone knew that there's no point doing it. It doesn't provide any value to actually generating signal at that frequency. So I think that's really cool. I think that's really interesting. So there you go. There you have it. That is one typing test with this particular keyboard using the ECM8000. Now, where do I go from here? What do I do with this investment that I've made with this microphone? Well, how about you let me know? I've got a whole bunch of keyboards that have been tested throughout this channel's history. Go find them and tell me if you want me to do a typing test with that particular keyboard. Specifically, like, you know, if it's an OEM keyboard or that kind of thing. Some of them might not have any more because I've lent them out to people on an indefinite basis kind of thing. But for example, I've got the entire Switch collection keyboards that I've got, you know, I think 7 or 8 keyboards there with some of the standard switches of the time in a 60% with plastic shell. I could run through those, or if there's anything else that, you know, is in what I have, including the top rate keyboards that I've got. Probably not NovaTouch, because the NovaTouch is in a bit of a shambles, but I do have the 660C, which I'll have to bring back from work. I've got my HHKB here as well. So there you go. That is the sound test with the ECM8000. I hope you enjoyed that. And if you like seeing more of this kind of keyboard science type of thing, we got more ideas about what I can do with my microphones relative to keyboards and switches, please let me know. Comment below. And of course the usual drill, like, bell button, subscribe. Right, that's it. Thanks very much for checking out this video. And of course, as usual, until next time, happy clacking.